Saxon Algebra 1, Lesson 98. Greetings, my students. I'm happy to be with you here for this lovely lesson. This lesson is a great lead-in to something we're going to be spending a lot of time on next year. So you're getting a good head start into that, and it'll make lots more sense next year. The two topics are related, but I'm going to address them as two separate things. The first thing we're going to do is talk about 2 points, the distance between 2 points. And let me show you what the problem looks like, and then I'll tell you everything you need to know. Find the distance between the points whose coordinates are 4, 2, and -3, -2. Okay, the first thing that we want to do is graph the points. All right? It doesn't have to be picture perfect. It doesn't have to be the Mona Lisa, as I like to say, but it helps if it's accurate. Okay, so I am using the lines in my notebook paper to be the marks on the y-axis, and then I'm trying to do them the same distance apart. They're a little too far, but that's okay. I'm going to be neat and orderly about it. So I'm going to graph these 2 points. Okay, 4, 2 would be right there, and -3, -2 would be right there. So what I'm trying to find is the distance from there to there. That's my goal. Now, that's not a very easy thing to do just using the graph. We can't count using these scales to do that. That just doesn't work. So we have to find another way to calculate this. Now, here's the secret. We're going to draw in the triangle that fits with this. So what I do is I start at this point and I go straight across, and then I go down from there. Now, I remember so distinctly learning how to do this, you guys, and I was confused because I didn't understand why we didn't go up and over like that. That was my natural instinct. I don't know why. Maybe I'm upside down. But I immediately saw the triangle that way. And I was very confused as to why it had to be down here. Spoilers, it doesn't. This works too. This would work too. Normally we just draw it this way because it's kind of grounded, I think, because, you know, the triangle comes down rather than floats up. But it doesn't matter. You can do it the other way too. And when you see the calculation, you'll realize, oh, it would work out exactly the same. Okay, now what we have is a right triangle, and that means we can use our Pythagorean Theorem, which we just learned. Was it last lesson? Yes, it was last lesson. Pythagorean Theorem is perfect for finding one of the sides of a right triangle. And it is a right triangle. We made sure it turned into one when we drew those lines. And now we have to do the whole thing of making sure we know which are the legs and which are the hypotenuse. Well, we'll call that one A and we'll call this one B. These two are the legs. This is the one that's opposite the right angle. And so this is the hypotenuse. The hypotenuse is the one that we want to find. So that sounds really great, right? This is the A and that's the B, and that will help us find the C. But how do we know how long this is? Oh, this length I can calculate on the graph because this is a straight line that matches to these units, right? So 1, 2, 3, 4, 5, 6, 7. A equals 7. Oh, that's so easy, right? What about B? We count the change from the lower dot to the upper dot. 1, 2, 3, 4. We don't have to worry about plus or minuses in this because we're going to square everything. And once you square something, the negatives go away. So we don't have to worry about, you know, this, but this goes into negative numbers and this is in positive numbers. No, that doesn't matter. Just count the number of units long this line is. 1, and see, I'm counting it up here, but it's along this length of the line. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4 units long. Okay, you don't start counting where you begin. You count after the first, we're counting these spaces, right? I had a student once who was getting confused about this, and she always wanted to start counting here, 1, 2, 3, 4. And I was explaining to her, no, you don't count where you start. You count after like the first jump. And I said, it's like in board games. You don't count the space where you're starting. You count your jumps, right? So if this was a Monopoly piece and I was moving, you'd go 1, 2, 3, 4. And I said, right? That's how you play board games, right? And she looked at me and she said, no, I count the first place is 1. So what we discovered is she had been like kind of cheating herself out of moves in board games for her whole entire life. And we laughed really hard. So we learned an important lesson that day. You don't count the starting place. You count the jumps essentially, right? 1, 2, 3, 4. Okay, and now going back to my dotted line scenario, if I had counted these, I would get the same thing, right? 1, 2, 3, 4. I'd get 4 for this length. And 1, 2, 3, 4, 5, 6, 7. I'd get 7 up there. So either triangle will work. You'll see me going down. You'll see John going down. But you do what works for you. Okay, now we can fill in the blanks. 7 squared is A, plus 4 squared is B. Now I can actually do the numbers. This is 49 plus 16, right? And so that equals 65. Well, I shouldn't write it like that. That's C squared still. And then I write 65 equals C squared. And now we're doing that thing that we learned how to do a few lessons back. We're taking the square root, which tells us the answer for C is positive and negative square root of 65. But there's no way that this is negative square root of 65. So we can write with certainty that the answer is square root of 65. Could we reduce that? Maybe. Let's check and see. Clearly 5 multiplies into that. 5 times, I'm dividing in my head, 5 into 50 goes 10 times. If I do that and subtract it, I get 15 less. 5 into 15 goes 3, so that means it's 5 times 13. Those are both prime numbers, and we don't have any pairs. So what that tells me is I can't reduce, and that's my final answer. Yay! Okay, this isn't too terribly hard. Let's do another one. And next year we're going to learn an easier way to do it so that we don't have to make the picture. Okay, this time we're supposed to find the distance between the points 3, -4, and -5, 2. So again, I didn't write the steps. I always do that. I get so excited at the beginning to write out the steps, and then I get excited by the problem and I forget. So what we did first, we graphed, then we counted to get the lengths of the sides, and then we used Pythagorean to solve. Okay, let's do it again. And like I said, next year we'll use a formula. Yes, next year we'll use a formula to do that, and it'll be faster and easier. But this will make the formula make a lot more sense. Okay, 3 and -4 would be there. And -5, gonna need one more. 1, 2, 3, 4, 5. And +2 is right there. Okay, again, it doesn't really matter the positives and the negatives on the grid. What we're really interested in are the lengths of these sides. I'm going down, like I said I would. John, in the book, just so you see, John decides to go up for this one, okay? Like my student self. So the important takeaway is it doesn't matter if you go up or down from this diagonal, if you think of it like that. The important thing is that what we make is a right triangle, because Pythagorean theorem only works for right triangles. That is so important that you get that. And that was something that was sort of vague for me when I was a student. Nobody ever hit me over the head with that. So I'm hitting you overhead with the 2x4 of knowledge that what we have to create here is a right triangle, because Pythagorean only works for right triangles. Okay, now we're gonna count the lengths of these sides. We can do it from these unit measurements. We know need to go from there to there. 1, 2, 3, 4, 5, 6, 7, 8 is this length. And then up and down, 1, 2, 3, 4, 5, 6. So this is 6. Again, don't let the positives, negatives concern you or freak you out. That doesn't mean not equals. That means I was going to write plus again, and that was wrong. Okay, so we fill in. Again, A and B don't matter. We just need to make sure that we remember the hypotenuse is C. Okay, so this is 6 squared plus 8 squared equals C squared. This is 36 plus 64 equals C squared. This is a fun this is a fun problem because it's going to work out evenly because we get 100 equals C squared, and then we take the square root and we remember, oh yeah, we would have positive and negative roots, but this is a picture that can't have a negative length, and so we get C equals 10. Yay! Okay, that is how we go about finding the distance between 2 points. That was part A. Now we have part B. Don't you love it that our lessons are so long now and you get to spend so much more time with me on these videos? Just think of how much fun we would be having in class. Oh, and that we will be having for sure next year. I got vaccinated over the weekend. So I got the Johnson & Johnson 1 and done. So I still have to wait 2 weeks until till it comes all the way up to speed, right? But I'm on my way. Okay, there is a formula that we can use not to find, let me go back to one of my pictures. This formula will not tell us the length of this line. That's a different formula that we'll learn next year. It's called the distance formula. The formula that we're going to use will help us find the slope of this line, and it's called the slope formula. So the distance formula will help us next year do this in a simpler way. That will be called the distance formula to find the distance of a line like that. But what we're going to do now is talk about how to find the slope of that line, right? And we know that the slope is important because when we write the equation of a line, there it is. We need the slope in order to write the equation. Okay, cool. The slope formula is something that we use, again, when we're given 2 points, just like we did with the last one, right? Remember how we were given 2 pairs of points? Like that, and told. In this, we're going to be given 2 pairs of points, but we're going to use them in a different formula. Oh, I'm sorry, that's not right. This is our slope formula. That's the name of this. We use it to find m, just like I said, and I'll explain what this means. It's really easy, don't worry. Find the slope of the line that passes through the points, -3, 4, and 5, -2. Oh, wait. Yeah, this is the exact same pair of points we used in the last problem, all right? This time, we're not trying to find the length of the line between those 2 points. We're trying to find the slope of that line. Okay, here's how we do it. We name these points. We know they're already that they're x and y, right? We give this one a pair of 1s so that we see those are the 2 that go together in this pair of points, and then these guys are 2 because they're in this pair together. Now, what if we got mixed up and we called these y2 and these y1? That's okay. It doesn't matter which subscript you put on it, as long as the 2 that are a matching pair have matching subscripts. All right, so it's important that these numbers match because these guys are buddies. But these could be the 2s and these could be the 1s, and we would still get the same answer. One of the miracles of modern math. Okay, so now what we do is we just take these values and plug them into this formula. Caution, notice I've resorted to uppercase writing. That's when you know I mean business, you guys. I've got an asterisk and a puffy cloud of knowledge around this. Please use buckets in this formula. I will tell you right now that one of your older, no, not necessarily older, but one of your colleagues in an upper level course working with me lost points on a midterm problem because they did not use buckets on this formula. I'm telling you, it will get you if you don't use the buckets. And I'll tell you the reason why. So what I'm doing is I'm using buckets to set this up. And this problem is a good example, right? See how my buckets match that exactly. Now I fill in. Y2 goes here. Y1 goes here. Y1 is 4. X2 goes here. And X1 goes there. Okay? See how I carefully filled them in? Look at how there are minus signs in the formula and minus signs in our values. That is a recipe for disaster. And that's exactly what happened with this student. They didn't do buckets and they ended up with only one minus sign down here, and that ruined their answer. Buckets are always a good idea, but especially whenever your formula has minus signs, that's when you really want to be careful and use buckets, okay? When your formula has minus signs. Because if you have minus signs in your formula and then minuses in your values that you're plugging in, it's easy to create a mess. With buckets, this is a piece of cake. -2, -4, we're on the meadow, we're going down and then down some more. This is -6. These two combine and become +8. See how easy it is when you have your buckets to keep all that straight? And then our final answer with that reduced, and I like to see the minus sign in the middle. It would be -3/4. See how I don't like floaty numbers, but I do like floaty minus signs. So this is the best way to write that, okay? It's the same value as this, but just like simplifying the numbers, or reducing the numbers rather, moving the minus sign to the middle just clarifies, okay? And what we're going to do for our last example is we're going to use these same points, but we're going to switch the sub 1s to be the sub 2s and the sub 2s to be the sub 1s. So what we're going to do, let me just copy it again. We're going to illustrate that the order does not matter. Okay, so this time, this first pair, they were the 1s before, but now we're going to call them the 2s. And this pair was the 2s, and now we're going to call them the 1s. Notice that the pairs have matching subscripts, but we've switched the subscript from one to the other. Okay, ready? M equals, here we go with the buckets. Don't forget, don't skip. I want you to always remember, I'm not going to tell you who did it, but I am going to tell you this is a student who does not usually make mistakes. This is a student who is careful and precise and gets really, really good scores on review problems and math tests, and just neglected the buckets and fell into the trap. So please don't be like that student, who you know and love. Okay, so there's our formula. We start with y2, that is 4. The next comes y1, that is -2. Then x2 is -3, and x1 is 5. So let's see what's happening. These two go together and make a plus, and we get 6 and -3. Now we're in the meadow. We're in -3. We go down 5 more, -8. And that reduces and simplifies to -3/4. So look what happens. The numbers were exactly the same, but in the first scenario, the minus sign came through on the top, and in the second scenario, the minus sign came through in the bottom. That's exactly right. That's the difference that we get depending on which order we take the points in. We will get the same number once we simplify, but in our calculations, things might look slightly different with our minus signs. So you'll get the right answer both ways, though. And that's the moral of my story. Just be consistent with your subscripts, but it doesn't matter which one you pair. All right, like I said, the slope formula and distance formula, which we'll learn next year. These two concepts are closely related, and they live at the heart of what everyone at the college level expects a high school student to know. So this is like, bam, one of those lessons where we are doing exactly what everyone wants us to do. And all of the teachers that come after this will be like, oh yeah, you learned your slope and distance formulas really well. So I'm glad you're paying attention. Okay, 98 is over. Yay! That's all I have to say to you now. Goodbye.